So let's use the distance formula to solve for the distance between two order pairs. Now, we can plot the two order pairs on the graph, so let's do that just for a moment. And then we're going to solve for how much distance actually between them. So let's solve the first order pair, and I'm going to call this x subscript 1, comma, y subscript 1. So that's going to be order pair 1. And this one's going to be order pair 2. So x subscript 2, y subscript 2. So let's plot order pair 1. What I'm going to do is I'm going to start right here at the center. This is where x and y both are 0, and let's start here. And it says x is -3, so I know I'm going to go to the left. 1, 2, 3. And from here, I look at y. Y is negative, so I'm going to go down. And it says it's -1, so I'm going to go down 1. So let's put our point right there. Now let's go back to 0, 0, and let's start on the second order pair. It is 2, comma 3, so x is +2. We're going to go to the right, 1, 2, and from there, y is +3, so I'm going to go up 1, 2, 3, and I'm going to plot my point. Now, I'm going to draw a connection between these two the best I can. My lines are not perfectly. Whoops. Oh, that's terrible. It's not a very good line. Okay. But you kind of get the point. I should have used a ruler. I would if I was on paper. I would use a ruler to make sure it's a good straight line. But anyways, so there is my line as passing through these 2 points, but I don't know how much distance it is between these 2 points. Okay? So we're going to use the distance formula. What is the distance formula? It is little d, and it's equal to the square root of the x values, right? The change in x values. So I'm going to have x subscript 2 minus y subscript, or excuse me, x subscript 1. I said change in x, just a habit of y, x and y, because they're order pairs. And then I'm going to add it to the change in the y values. So y2 minus y1. And something I left off when I was reading the x values we're going to find the change in the x values, square that number, then we're going to add it to the change in the y values squared. Okay? So what I'm going to do is I'm going to set this up. Give myself plenty of room. Alright. Sorry about the silence. Trying to write right quick. Alright, so my x2 is 2. My x1 is a -3. And let me change the color right quick so we can see the changes. Let's redo that 3. Let's make this 2 a red 2. Okay, and then over here on the y values, I have 3 for y2 and -1 for y1. My next step is that I see that I have a negative times a negative. I need to clean that up. That becomes positive. So now I have 2 plus 3, which is 5 squared, plus 3 plus 4, or excuse me, sorry, 3 plus 1 is 4. And then I'm going to square it. Alright, so 5 squared is the same as saying 5 times 5, so it's 25. 4 squared is the same as saying 4 times 4, which is 16. Now we're going to say 25 plus 16 gives me 41. And then when I do the square root of 41, it gives me a decimal place. So the square root of 41 is exact. This is exact form. Of course, we're not totally sure where to plot that on the graph, but if I was to say my distance for these two, between these two order pairs, is the square root of 41, this would be my exact answer. Now, my approximation answer, approximately, this is if and only if you're asked to round to the nearest whatever place, and it's approximate. We would say the square root of 41, and then we'd round. Let's round to the nearest hundreds. Okay, so that means I need to go out to the thousands in order to round to the nearest hundreds. Sometimes it asks us more or less. So I went out to the nearest thousands to determine what happens to the hundreds place. The thousands, I asked myself, is it equal to or greater than 5? And it's just a simple yes or no. And this number here is a 3. It is not equal to and it is not greater than 5. Therefore, we do not make any changes to the hundreds place. So my answer in approximation form is 6.40. That is the distance. The exact again is the square root of 41. So this is exact. So that's solving the distance between two order pairs using the formula. Now let's do the midpoint of an equation. So we have this equation, guys, and we can plot these points again on the graph. So let's do it. Let's plot these two order pairs on the graph. I'm going to come over here to 0, 0. I got a positive 7 for x. I'm going to go 1, 2, 3, 4, 5, 6, 7. And from here, I'm going to go to the y value, and it's a negative, so I'm going down, and it's 2. I'm going down 1, 2. Plot my point. Go back to 0, 0, and let's do the second order pair. It's a positive 9 for x, so we're going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. And from there, I'm going to go y. Y is positive, so I'm going to go up. And it's 5, so it's going 1, 2, 3, 4, 5. So what we're wanting to know is what is the midpoint between these two? And this is a really, really good question because, I mean, in real life, when I was growing up, I always lived out in the country, and we had to literally drive 40 minutes to school, and if anything ever happened, we always had a meeting place that we could meet, and this was back before cell phones. So you would want to figure out where would that meeting place be right here. If for some reason that you have a spouse or a child, and you say, okay, if something happens and we can't get home, where are we going to meet at? We'll meet at the halfway mark right here. Well, to determine that halfway mark, we're going to use a capital M. And I'm going to get this set up right quick. Let me get this, and I'm putting in everything we need for, and then I'm going to explain it to you. So thank y'all for being so patient with me. So the midpoint says that we are going to take two order pairs, because that's all you need is two order pairs, and we're going to add our x's and x values together and divide them by 2, and we're going to add our y values together and divide them by 2. Okay? So I'm going to call this order pair 1. And I'm going to call this order pair 2. So now let's plug it all in. Get this written out. Alright, my x value 1 is going to be 7. So let's put 7 in its place. My x value 2 is 9, so let's put 9 here. And then I want to put my comma. And do y'all notice what's going on? We got an order pair here, right? Order pair is always x comma y unless you're doing the inverse. So now I got my y1, which is negative 2, plus my y2, which is 5. Now let's clean this up. It says that we have 7 plus 9, which is 16. I have negative 2 plus 5 is 3, and let's put the rest together. Alright, we try cleaning it up if it will reduce, and I notice that 2 will go into 16 8 times, so I'm able to clean that one up. Now 3/2 does not reduce. If I need to plot this order pair, I would want it in fraction or in decimal form, but my final answer needs to be exact, so this would be my final answer. So this is my x value and my y value of where the center is between two order pairs. Okay, so now if I wanted to plot this on here, I would know that we need to go to where x is positive 8. So we go 1, 2, 3, 4, 5, 6, 7, 8. And then from there we're going to go up. Well, 3/2 is actually 1.5, so we're going to go up about right there. This should be about the meeting place, should be the halfway point between the two order pairs. I want to explain something to you right quick. This is an endpoint, and this is an endpoint. Why is it called an endpoint? Because that's the endpoints of your line. And then here's our center of the line. So thank you.